Problem 33 tells us that we have, looks like two urns. We've got urn 1, so let's draw urn 1. We'll label it urn 1. And in urn 1 there are 5 red balls and 5 white. Okay, 5 red and 5 white. And then in urn 2, 12 white. That's it. Okay, so here's the experiment. We select the ball from urn 1 and place that ball into urn 2. Then you take a ball from urn 2. What's the probability that the second ball is white? Well, let's start by writing down what it is we're looking for. We're looking for the probability that we get a white on the second ball. So, I just wrote that down. You have to come up with your notation. Somehow you have to get the second ball is white. I don't want to put the 2 here. That reminds me of 2 white balls. But if I subscript something, it just tells me which number it is. The second one is white. Okay, I'm going to try this with the tree diagram. So I'm going to start here. And here's drawing from urn 1. So draw from urn 1. You could get a red or you could get a white. The probability of a red is 5 out of 10, right? In the urn 1, there's 5 red and 5 white. 10 balls altogether, so 5 out of 10 reds and 5 out of 10 whites. Now, you take that ball and you put it into the urn 2. So in urn 2, we could get a red or a white, a red or a white. Now, let's think carefully about this. What's the probability of getting a red? Well, we got a red on the first, and here's the experiment. In the first urn, you pick a ball. Now, whatever ball you get, you put it into the other urn. So we're on this branch right here. So we're saying we got a red on the first, so now we put a red in here. So now there's 13 balls altogether, 1 of which is red. So this probability is going to be 1 out of 13. And then there's 12 whites out of 13. And now on this branch here, we got a white on the first. And we take that white ball. So we got a white on the first. We take that white ball, put it in here, the second urn. So now there's 13 white balls and no reds. So the probability of getting a red here is 0, right? There's no red balls in there. And over here, it's 13 whites out of 13. That's 1. That's for sure going to happen. So now, how can we get a white on the second, right? That's what we're looking for. How do we get a white on the second? Well, we could get it here. Here's a red on the first and a white on the second. So we could get it right here, or we could get a white on the second, a white on the first and a white on the second. That's right here. We'll mark that one. So here's our probability. It's going to be 5/10 times that 12/13, or plus the 5/10 times the 1. My calculator shows me that to be 0.9615. Problem number 34 says we've got an urn. Let's draw our urn. And it contains 5 red and 3 green. So it looks like n is equal to 8. We've got 8 balls altogether, and 1 ball is selected at random and then replaced by a ball of the other color. Then a second ball is selected at random. What's the probability that the second ball is green? Okay, here's what we're looking for. What's the probability that we get a green on the second ball? Let's do it again with a tree. So here's our first draw. So in the first draw, we could get a red or a green. Probability of a red? Well, there's 5 reds, right? There's 5 reds and 8 balls altogether. So this is going to be 5/8. A green, 3/8. Now let's go to the second draw. So in the second draw, if we got a red on the first, we could get a red on the second or a green on the second. Here's the deal with the experiment, though. We choose a ball on the first, and then we take a ball of... Okay, a ball is selected at random and then replaced by a ball of the other color. So what we're saying is we got a red on the first draw. So we toss that red out and we put in a ball of the other color. We put in a green. So now what we have are 4 reds, because we got a red, we took it out, and we replace them with a green. So we have 4 reds, 4 greens. So the probability of a red on that second draw is going to be 4 out of 8, right? Because there's only 4 reds now. But the probability of a green, that's also going to be 4 out of 8. Remember, these add up to 1. And if we got a green, if we're down here and got a green on the first draw, then on the second draw, we could get a red or a green, a red or a green. And these probabilities are, now let's remember what we did here. So on our first draw, we got a green, right? That's what we're saying. We got a green. So we take this green, we take it out, and we replace it with a ball of the other color. We replace it with a red. So there were 3 greens. We got a green. We took it out. There's 2 greens left. There were 5 reds. We put in a red. So there's 2 greens, 6 reds. So what's the probability of a red now? There's 6 reds out of 8 balls, and there's 2 greens out of 8. So how do we get a green on the second? So to get a green on the second, we could get a red on the first and a green on the second. That's right here. Or we could get a green on the first and a green on the second, and that is right here. So let's look at these numbers on these branches. We could get a 5/8 times a 4/8, right? Do you see it? It's coming 5/8 times 4/8, or plus, we could get 3/8, right? A green and a green. So 3/8 times 2/8. That's how we get there. So 3/8 times 2/8. And when I added these together, I got 0.4062, or 4063 if you like. Now, number 36 says that this light bulb manufacturer knows that 0.05% of all the bulbs are defective. Let's write that down. The probability of being defective is 0.05%, so 0.0005. Tenths, hundredths, thousands, 10,000. 5 bulbs out of every 10,000, defective. We'll give some information about how they test them and such. And it says, if a randomly selected light bulb is tested and found to be defective, right? So we know the bulb is defective. What's the probability it really is defective? This is a conditional probability, and we know how to do these. It's intersect them in the top. It's the probability of defective and a positive result, divided by the probability of a positive result. So I'm going to draw a tree to get all these numbers. So let's start here. I'm going to draw my 2 branches, and then the question is, what do I put here? Do I put defective and non-defective, or do I do a tree like this that says I get a positive result or a negative result? Well, if I try this one here, what am I going to put for positive result? When I go back and look at my information, getting a positive result depends on whether it's defective or non-defective. Sometimes the test will tell me that a defective bulb it will test positive, saying that it's defective, or sometimes a good bulb gives me a positive test saying that it's no good. So these numbers here, I don't know, but they depend on what comes here. So this is what has to go first, and I know these numbers. We're given right up here that the probability of defective is 0.0005, so non-defective is 9995, right? They add up to 1. So those numbers are given. That's how we know to go there. So let's erase this one. We're not going to need that one. And now we're told that if the bulb is not defective, if it's a good bulb, now good bulbs are down here. That's the way I wrote this one, not defective, not defective. So if the bulb is good, then we can get a plus or a minus. So the way I'm writing this is a positive result means the bulb is no good. So this tells us that the bulb is good 99% of the time. If it's good, we'll get a negative result. If it's bad, it'll come up positive 1% of the time. Then if the bulb really is defective, we can get a positive result or a negative result. And if the bulb really is defective, this test will give us a positive result 99% of the time and a negative result 1% of the time. So let's go back here to our conditional probability and see if we can get these numbers. First of all, for the intersection of D and plus is right here. So that number is going to be let's see if I can get that to work, 0.0005 times 0.99 over, and now our denominator. Our denominator is how to get a plus. Well, look, we can get a plus result right here and right here. So let's get those numbers. And when I calculated that to 4 decimal places, I got 0.472.